Hey everybody, we're going to do a little activity together. So in your note packet on 2.2 down here at the bottom of the paper, you should have these two pictures. What I want you to do is see this dotted line? I want you to fold your paper and use your fingernails, give it a good crease along there, and maybe fold it back the other way. Again, give it a good crease so that you can easily tear this out. And once you tear it out, you're going to have it like this. And then what I want you to do is fold in between the square and triangle so that you get those into two separate pieces so that you have two pieces that look just like mine right here. Okay, set the triangle to the side for a minute and we're going to focus in on the square. To start out, we know a square, all four sides are equal. Well, in this particular square, I'm going to tell you that each side measures 1 unit. So we can go ahead and mark on this square that each of these sides is 1 unit. Now, what would happen if I were to slice this square right down its diagonal? Okay, well, I don't have scissors handy, so let's fold it instead. Okay, we're going to fold it right along the diagonal from corner to corner so that it's like I slice the top half of it off. Now, take a look at that. If you look at that, what shape would you call this? Well, yeah, you guys are saying a triangle, but specifically, what kind of triangle did we create? We just created a right triangle. How do I know? Because squares start out with 4 right angles, so I know this is a right angle here. This is a right triangle. So if I start with a square and I cut along the diagonal, the remaining shape is a right triangle. Now remember, our square had all 4 sides equal to 1, so I already know that this side and this side are 1. All right? That's pretty neat. Now let's talk about what else we know about this triangle. Let's see, is there any way I know the measure of this angle up here? Well, let's take a look. When it was still a square, what was the measure of the angle? It was 90. And we know a square, when I draw its diagonal, it bisects that angle. So if it bisects that angle, how much is it once I cut half of it off? Exactly, this is going to be a 45-degree angle. All right, what if I asked you what was the measure of this angle down here? What would you tell me? Yeah, same thing, right? You bisected the angle down here, and therefore this one is 45 degrees. So now let's take a look at my triangle. I have a right triangle that have angle measure 45, 45, and 90. Now, these two are equal because there's a special property, right? If these two angles are equal, the sides opposite will also be equal. So that's pretty cool to know too. All right, now one more thing, one more property we can find about this triangle. I know all 3 angle measures, but I only know 2 side measures. Is there a way for me to find the length of this side? Think hard for just a minute. Is there anything you know how to find a missing side if you know 2 sides of a right triangle? Oh, yep, my cat's trying to get in the video. Go away. All right. Did anybody say Pythagorean theorem? If so, you're right. Do you guys recognize a squared plus b squared equals c squared? So how could I find the length of this? I'm going to plug in 1 and 1 for which ones? That's right, for a and b. Why? Because C always has to be the hypotenuse, and the hypotenuse is across from the right angle. So the 1 and the 1 have to go in A and B. Does it matter which one goes in which? Nope, makes no difference. So we're going to have 1 squared plus 1 squared equals C squared. Now, why am I doing this? Remember, what did I ask you to find? We're trying to find how long the side is. Then I'll know the length of all 3 sides and the measures of all 3 angles, and that's going to be handy to know. Okay, 1 squared is 1, 1 squared is 1, so I have 1 plus 1 equals C squared. 2 equals c squared. How do I solve for c if it's c squared? What do? We take the square root of both sides. And anybody know square root of 2? No, not without a calculator. We're just going to leave it looking just like square root 2 equals c. All right, I can label this side. The measure of this side is square root 2. You have just created what we call a very, very special, he's very special right triangle. It's a right triangle, duh. And he has a special name. He's named after his angles. He is a 45, 45, 90 triangle. Okay, you will hear this often in this class and in future math classes when they refer to a 45, 45, 90 triangle. this is what they're talking about. And this is where it comes from, how we know the measures of all three sides and all three angles. Now, if you remember similar triangles, okay, similar triangles, if I draw any 45, 45, 90 triangle, I can draw it bigger or smaller. I can shrink it either way. And what happens? All the sides are proportional. Okay, so we're going to use proportions because any other 45, 45, 90 triangle will be proportional to this one. All right, set that one to the side. He's important. Now pull out this one. All right, we're starting out with an equilateral triangle. And I'm going to tell you for this equilateral triangle, all three sides measure 2. So let's go ahead and mark that. All the sides measure 2. Okay. Now, real quick, can you tell me the measure of these angles in here? They're marked that they're all equal because it's an equilateral triangle. It makes sense. All three sides are equal. All three angles are equal. How could I find out what the measures of these are? Do you know what the angles in a triangle measure or add up to? They add up to 180. So 180 divided by 3, how much are they? Each of these are 60 degrees, right? Okay, we're going to do something very similar from our last one. And that is we're going to slice this guy right in half. Are you ready? Again, we're going to use the folding technique because I don't have scissors. We're going to fold them in half. All right. What shape did I make? I made a triangle, didn't I? What type of triangle? Is anything special? He is a right triangle. How do I know this is a right angle? If you remember, in an equilateral triangle, okay, the altitude right here, or excuse me, other way. If it bisects, we said we were in kind of half, right? If it bisects this, it's going to create a right angle across here. So we know this is a right triangle. Okay. Do I know anything else? Let's see. So far, I know this angle is 60 and this is 90. Well, all three angles have to add up to what? 180, right? Or you can think about this used to be 60. What happens when we cut in half? The measure of this angle up here is now going to be 30. All right. Anything else I know here? What about this side down here? Do you guys know what the measure of that side is? Let's see. It used to be 2, right? And then I cut that thing in half. So what is it now? That's right. This side is going to be 1. All right. We're getting closer to solving our triangle. We've got all three angles. We've got two sides. Darn it, I'm missing the measure of this side. Wait a minute, it's a right triangle. I know two sides. How do I find that third side? Pythagorean theorem. You're right. Here we go. A squared plus b squared equals c squared. And what has to go in the c position? The hypotenuse. The hypotenuse is across from the right angle, so c better be 2. So I'm going to put 2 in here. All right, 1, does it matter? Nope, it can be an a or b. And I'm trying to find that one. All right, 1 squared is 1. 2 squared is 4. Let's subtract 1 from both sides. I get b squared equals 3. Take the square root. And my missing side is square root of 3. Very nice. Okay, we just did it. We found the sides of all three, or sorry, the measure of all three sides triangle. We found the angle measure of all three angles in it. And we created a second very special right triangle. Do you know what he is called? Very similar. Take a guess. If this one was called the 45, 45, 90, guess what this one's called? He is called the 30, 60, 90 triangle. Pretty cool, huh? Okay, we are going to use these two special right triangles in solving for the measures of other triangles that are similar to them. So turn the page, keep these handy, turn the page to the next page in your notes, and it looks like this. Do you see this? Okay, go to problem number 1. Label the matching special right triangle, that's the one shaded, then find the missing sides. So take a look. This is my original problem. And we already have drawn for you a little, what we call a reference triangle, okay? It's what we're going to use to help set up our proportion, our similar triangles. Now, if this is 30 degrees and that's 90, then I automatically know, since they add up to 180, that this is 60. So which one is this? This is my 30, 60, 90 triangle. Okay, remember those special triangles? Go find your 30, 60, 90. Here he is. You have him. Okay, we need to turn him so that he matches what this one looks like. Do you see that? You can't do similar triangles unless they match. So let's rotate him. Now he's the same shape as this. 30, 60, 90. Yep, my angles match. And he has the same shape. And so what I'm going to do is I'm going to take this little bitty reference triangle. I'm going to label the sides to be the same as my reference triangle. So that makes this 1. What was over here? 2. Yeah, you got to read the numbers upside down. You can do it. And over here, square root 3. These 3 numbers right here from my reference triangle, my 30, 60, 90, I can use here. Now I use the properties of similar triangles. How can I solve for missing sides in similar triangles? Well, I set up a proportion. I find the 2 that match, that don't have a variable, and I say, okay, 2 to 1 is equal to, now I go find a variable that I want to solve for. Let's start with m. And which side does m match up with? It matches up with this side. Now, if you start this one left to right, you have to continue and go left to right. So we're going to do the same thing, go m over 2. Now, you guys remember how to solve proportions? Cross multiply. 2 times 2 is 4. 1 times m is m. Hey, you're done. 4 equals m. Not too bad, right? Okay, now let's solve for n. We go back to the 2 sides that we know. We need 1 from each triangle, and we set that up. 2 to 1 equals, now what am I going to find? I need to solve for n, which side matches? Square root 3, and I went left to right here, so I need to go left to right again, n over square root 3. And what do I do now? Cross multiply, so we're going to go diagonal. 2 times square root 3 makes 2 square root 3, you guys. 2 times square root 3 is 2 square root 3. Equals 1 times n, n. Hey, n is already solved. I'm done. All right, I want you to continue on and see if you can do the same for these problems. So you're going to start out with your reference triangle. Okay, first figure out which, is this the 30, 60, 90? No, he's got a 45, so you're going to use this one. Use your 45, 45, 90. Turn it so that it matches your picture. There we go. Now they look the same, right? And I'm going to come over here and I'm going to label those 3 sides with these 3 numbers right here. Okay? And then I'm going to set up my proportions and solve for both x and y. You got this, you guys. You're awesome.